This is a film showing how Canadian National Railway mainline service was restored after a collision of two freight trains. The collision occurred in the town of Prescott, Ontario, on the busy mainline in eastern Canada. Both the mainline tracks were torn up, completely blocking the mainline service. One of the trains was stationary whilst the other was traveling westward but desperately trying to stop. However, as the westbound train was a couple of miles long, it could only slow down before hitting the stationary train head-on. Both trains were headed by two engines, and the force of the collision was such that the two stationary engines were thrown from the track and partially buried in the ground, whilst the two engines on the westbound train were derailed but remained upright. In total, 4 engines and 16 cars were derailed in the collision. Fortunately, no hazardous materials were involved and none of the personnel in the engines were killed or seriously injured. Before the undamaged rail cars from the westbound train were pulled away, it was clear that the westbound train was switching from the main line where it belonged to the occupied siding where it didn't. The cause of the collision is under government investigation. However, it seems likely that the westbound freight train was erroneously switched onto the siding occupied by the stationary train due to the switch at mile 113.36 being left in the wrong position. The 4 engines involved in the crash were worth several millions of dollars, although some were decades old. They weighed 125 tons apiece and carried up to 5 tons of diesel fuel. 2 of the engines were more or less upright, while the other 2 were lying on their side and were heavily damaged with trucks ripped off. It was unlikely that they could be economically repaired. The first step in the disaster response was to drain the fuel tanks, which hold 1,000 imperial gallons, or just over 4,500 liters of diesel. The collision occurred at 10:30 a.m., and by early afternoon, heavy equipment and personnel were flooding into the site of the derailment to restore the mainline service. No expense was spared to restore the service in the shortest time possible. With the excavators and crawler tractors on site, the first step was to clear away the vegetation to afford easy access to the tracks and derailed equipment. With site access, the next step was to remove the wrecked containers and derailed rail cars. All the derailed rail cars were treated as write-offs, so there was no effort and time wasted trying to avoid further damaging them. The winches on the cats were used to break the containers off the intermodal container cars and then pull both them and the cars to where they'd be cut up and trucked away. Winching was pulling one of the cats backwards, so it was time for some more brute force. If the cat's winches couldn't pull the containers off the rail cars, the excavator was used to prise off the containers. With the containers removed, the intermodal container cars were pulled away to be cut up for scrap. Once the containers were ripped open by excavators using their shears, the undamaged goods were recovered for onward conveyance to their destination. It was heartwarming to see the salvaging of the Costco baby wipes. There will be some relieved parents, no doubt. With the salvage of the contents complete, the containers and the rail cars were cut up into small pieces by the shears, and the pieces trucked away for scrap metal recycling. As many of the derailed cars had lost their trucks, the truck frames and steel wheels were scattered around the site, and these had to be policed up by the excavator. The restoration work continued throughout the night under strong construction lighting. By morning, the rail cars and containers blocking the two main lines had been removed and engine 3102 righted by the side boom dozers and excavator. The track restoration company trucked in prefabricated sections of track to provide temporary rail service. Once both the mainline tracks were temporarily repaired with these sections, railway crews would replace the 39-foot temporary sections with 1/4 mile long continuous welded rail to fully restore high-speed mainline service. The crew working on the restoration of the track were from a specialized company, and they were highly motivated to restore the service in the shortest period of time, as bonuses were available for early restoration. The short temporary prefab sections of track were joined together with pairs of fish plates that were bolted together on either side of the rails. Track jacks were used to raise up the sections to align the holes for the fish plates. Once the fish plates were bolted together, the tie plates were spiked down using a spike maul, just as they were when the railroads were first built in Canada 150 years ago. Bonding wires were installed on the fish plates for the track circuit that allows the detection of a train on the section of track. Pin braiding is used to weld the bonding wires to the rail. This process requires careful preparation to ensure a solid connection. With the sections connected together, ballast was dumped on the track and then spread using a spreader ditcher machine, and finally the tracks aligned with a production switch tamper machine. Ballast for the restored track was hauled down the track from a temporary stockpile located about a mile from the site of the collision. As this was a restoration, the ballast was being spread over the new sections of track to hold the track in place when the trains roll over it. The ballast was roughly spread over the track using an excavator and by pushing prefab track sections along the rails. The final spreading would be done later by a spreader ditcher machine. The area around the collision was a beehive of activity, with the rail bed being restored, shipping containers being pulled away, the upright engines being prepared for removal, and ballast dumped on the restored South Mainline. The priority was to remove the two salvageable engines from the site, as they were blocking the North Main Line and preventing restoration of service. The covered hopper car behind the upright engine had lost its trucks, so it was rolled over, pushed off the track, and then ripped apart by an excavator using its shears. The spreader ditcher moved at speed both forwards and backwards to shape and distribute the gravel track ballast that supports the ties in the railroad tracks. The two upright engines were simply derailed and were essentially intact, so those engines could be put back on the replacement track and then moved off-site. The two engines lying on their side were heavily damaged and seemed to be beyond economic repair, so they would be cut up and their pieces hauled away. To put the engines back on a prefab section of rail, a 150-ton rail maintenance crane was attached to the front of the engine. When the existing rails didn't match up with the rails on the temporary sections of track, the track crew cut off a short piece of rail using a rail saw and then spliced it into position using fish plates. Once rail service was restored on both main lines, the work of replacing the temporary short rails with long sections of continuous welded rail would begin. Once the ballast is roughly spread, a spreader ditcher machine with a plow in front and wing blades is driven along the track to smooth and level the ballast along the track. The operation is conducted while the machine is operating, moving both forwards and backwards. The production switch tamper packs ballast under ties in order to level the railroad track and to correct both vertical and horizontal alignment. When the machine determines that track adjustment is required, a short section of rail is lifted and the two vibrating tamping tines on each side of the tie are driven into the ballast. The vibrating tines are pushed together underneath the tie to pack the ballast underneath the tie, whilst the rail is lifted until the tamper finishes its work. Finally, after 33 hours, mainline service was restored on one track, and a freight train several miles long passed through the work site. The two salvageable engines needed to be put back on track so they could be removed. The engines were lifted by the cats using their side booms and pushed by excavators onto prefab sections of track. Once the tracks on the sidings were restored, the engines would be removed from the site of the collision. Overnight, the relaying of the North Main Line was completed and the two salvageable engines removed from the site over temporary tracks to the undamaged portion of the siding track. In the morning, the final adjustments to the North Main Line were completed and the track readied for service. The excavator's method to take down the trees was unique. A pair of excavators worked together to haul off the intermodal container car to where they'd cut it up for scrap. With the two salvageable engines removed from the site, the cutting up of the two heavily damaged engines lying on their side began. Rather than cut up the wreck-covered hopper car in situ near the South Main Line, it was decided to drag it away and cut it up well away from the track. The biggest piece of the train engine to remove was the 16-cylinder diesel engine block and attached alternator. To make these roadable, the block was cut in half with a torch and the alternator broken off using shears. Once the 3,000 horsepower engine was cut in half, the excavator threw 1,500 horsepower onto the junk pile of scrap metal to be hauled away. The train engine trucks were too heavy to take by road, so they were cut in half with a torch. It was pleasantly surprising to see a supervisor doing his job to ensure that the man cutting up the truck was wearing his eye protection. The train engine's frame was cut up with a torch, leaving the oil and grease smoking. smell of the burning oil and grease was quite overpowering. The ever-growing mound of steel wheels was impressive. There were lots of damaged ties and rails to police up. As mainline service had been restored, train movement regularly passed through the site. Since there were two parallel mainline tracks, rail service could continue along one track, whilst the temporary short rails were removed from the other track and replaced by 1/4 mile long continuous welded rail to fully restore high-speed rail service. Finally, 6 days out from the collision that tore up the two main lines, the main lines were fully restored with continuous welded rail. The work remaining was to restore the torn up siding and to finish policing up the site. As a guesstimate, the restoration work and loss of equipment and goods cost CN somewhere near $10 million.
Take me somewhere nice, to some tired island in your heart called Paradise.